Part 284, C3M1b7c8e13c9c6d3p34u. Line 22f1fa19c3m1b7c8e13c9c6d3p34u. Transition state theory, thermodynamic 5G Wow Seti. There's the alien radio signal. We'll get our notes going here. Okay, so this is about the long-distance communication algorithms from the WOW data. January 26, 2013. Today's February 16th. The keyword was VET, Brunauer-Emmett-Teller. Then it was Arrhenius law from the previous video, line 22f1fa19c3m1b7c8e13c9c6d3p33. Brunauer-Emmett-Teller, Raney, nickel, metals, 5G Wow Seti. January 31st, the keyword, the Arrhenius equation to Boltzmann constant to Fock state, Fock space in previous videos. Line 22f1fa19c3m1b7c8e13c9c6d3p34a. Arrhenius, Brunauer-Emmett-Teller, Eyring 5G Wow Seti. Keywords from Boltzmann constant went to Fock state, then to constituent particle, classical wave equation, then coherent state, Eyring equation. Now it's transition state theory. So line 22 f1fa19c3m1b7c8e13c9c6d3p34t. Eyring Arrhenius equations 5G Wow Seti. Did I fix that? Oh, forgot again. Okay, that's supposed to be formula in there instead of Eyring. So the keyword transition state theory, quote and diagrams are from Wiki. Here's the diagram here. It says products, transition state, and reactants. Okay? And it says reaction coordinate, and then there's an equation there. If you can read it, it's very faint. Figure 1, the reaction coordinate diagram for the bimolecular nucleophilic substitution NS, little n, and then 2. Reaction between bromethane and the hydroxide anion. Transition state theory, TST, explains the reaction rates of elementary chemical reactions. The theory assumes a special type of chemical equilibrium, quasi-equilibrium, between reactants and activated transition state complexes. TST is used primarily to understand qualitatively how chemical reactions take place. TST has been less successful in its original goal of calculating absolute reaction rate constants because the calculation of absolute reaction rates requires precise knowledge of potential energy surfaces, but has been successful in calculating the standard enthalpy of activation with the symbols, and the standard entropy of activation, more symbols, and the standard Gibbs energy of activation, which is more symbols. For a particular reaction, if its rate constant has been experimentally determined, the little plusy symbols, notation refers to the value of the interest at the transition state. Before the development of TST, the Arrhenius rate law was widely used to determine energies for the reaction barrier. The Arrhenius equation derives from empirical observations and ignores any mechanistic considerations such as whether one or more reactive intermediates are involved in the conversion of a reactant to a product. Therefore, further development was necessary to understand the two parameters associated with this law, the pre-exponential factor A and the activation energy E with the little a to the bottom. TST, which led to the Eyring equation, successfully addresses these two issues. However, 46 years elapsed between the publication of the Arrhenius rate law in 1889 and the Eyring equation derived from TST in 1935. During that period, many scientists and researchers contributed significantly to the development of the theory. The theory is the basic ideas between transition state theory are as follows. Rates of reaction can be studied by examining activated complexes which lie near the saddle point of a potential energy surface. The details of how these complexes are formed are not important. The saddle point itself is called the transition state. The activated complexes are in a special equilibrium, quasi-equilibrium, with the reactant molecules. The activated complexes can convert into products and kinetic theory can be used to calculate the rate of this conversion. Thermodynamic treatment. In 1884, Jacobus van 't Hoff proposed the van 't Hoff equation, describing the temperature dependence of the equilibrium constant for a reversible reaction. So there's the formula that he has, math equation, never mind, where these symbols is the change in internal energy, K is the equilibrium constant of the reaction, and R is the universal gas constant, and T is thermodynamic temperature. Based on experimental work, in 1889, Savant Arrhenius proposed a similar expression for the rate constant of a reaction given as follows. And there's the math equation again. Integration of this expression leads to the Arrhenius equation, another equation. So the keyword from Arrhenius equation plus Eyring equation to transition state theory to collision theory will be in our next video. Thank you for watching.